Greetings class, Mr. S here. For the next few weeks, we're going to be learning how to write and balance chemical equations. Today's mini flip is just going to look at the writing of chemical equations. So let's get started. One of the first things students often ask me is, Mr. S, how can I decide or how can I tell which side of the chemical reaction contains the reactants, which side has the products? Well, it's pretty simple. The reactants are always found on the left-hand side. The products of a chemical reaction are always found on the right-hand side. Between reactants and products, many of you know there's an arrow. This arrow is called the yield arrow. Thank you, Mr. Lincoln, for making a guest appearance today. Well, I would like now to write out a real chemical reaction. And for my first chemical reaction that we're going to write together, reactants on the left, products on the right, I'm going to choose the reaction between aluminum and copper 2 chloride. If I were to write this, I would write it two atoms, I should say, of aluminum, solid, plus 3 molecules of copper 2 chloride, CuCl2. And after the CuCl2, I'm going to write AQ. We'll talk about that in a second. Yields 3 atoms of copper, the metal, and 2 molecules of aluminum chloride, and I will also put an AQ after that. And class, you can read this as what they call a word equation. Of course, you know most chemical reactions, you're going to use chemical symbols like Al and CuCl2, but it can also be read as a word equation. 2 atoms of aluminum, solid, plus 3 molecules of copper 2 chloride, aqueous, yields 3 atoms of copper solid and 2 molecules of aluminum chloride, aqueous. Now you may notice that I did put these little S and AQ after the compounds that are in the chemical reaction. Well, anytime you read a chemical reaction, if there is a small s, a subscript s, written after the compound, that means the compound is a solid in the chemical reaction. If you see an L in parentheses, that means the compound is a liquid. If you see a G, you would expect that the compound is a gas. And this weird one here, AQ, that is a Latin term, aqueous. A-Q-U-E-O-U-S, aqueous. And what that means is dissolved in water. And when you see the word aqueous, or you see the symbol AQ, that means that that compound has been dissolved in water, and you would expect to see it as a solution. So to summarize that little bit, the state of matter of your reactants and products are shown, and they are shown using a subscript in parentheses, S solid, L liquid, G gas, AQ, aqueous. You may also notice these numbers in front of the substances. Many of you know that those are called coefficients. So the 2, the 3, and the 2 are called coefficients. And coefficients are what we use to balance chemical equations. And we'll learn a bit more about balancing equations in the days to come. It doesn't happen in this reaction here, but if there were no number in front of, no coefficient written in front of a substance, it would mean that there were one of them. So whenever you have a 1, the coefficient of 1 is assumed. Let's correct this. Back to our 2 aluminum. So picking up here with our anatomy of a chemical reaction, there's really only one other thing that we want to talk about. We've mentioned our states of matter. We've mentioned that coefficients are numbers written in front of the compound to tell how many of each of that substance participate in the chemical reaction. Again, it's how reactions are balanced. And finally, we want to cover something called a reaction condition. To illustrate reaction conditions, we'll write a new reaction here. If I took 2 molecules of ammonia, that's NH3, the G signifying a gas, it will yield 3 molecules of hydrogen gas plus 2 molecules of nitrogen gas. But this reaction won't happen unless you heat this reaction mixture up to 300 degrees. If you were going to perform this reaction in the lab and you needed to know that you had to heat it up to 300 degrees, how would you signify that? Well, above the yield arrow, you would write the condition. In this case, 300 degrees C. Anytime any information is written above the reaction, the yield arrow, it is called a reaction condition. Reaction condition can be several things. Usually it can be a temperature that you have to heat the mixture up to. It could be just the word heat. So instead of 300 degrees C, you could write heat. Sort of an unspecified amount of heat would need to be added. Once in a while, above the reaction arrow, you see something different. You don't see heat, you don't see a temperature. You might see something like this. If I take hydrogen peroxide, that same peroxide that you might have in your medicine cabinet at home. That hydrogen peroxide can break down into water plus oxygen gas. Water is a liquid and oxygen is a gas. It turns out that that reaction doesn't happen very quickly. Luckily for you, this way your hydrogen peroxide on your shelf at home would stay okay. However, if you add a piece of manganese, a piece of the metal manganese to that mixture, that reaction happens much faster. In this case, manganese is not only a reaction condition, it's also called a catalyst. And a catalyst is anything added to a chemical reaction that speeds the reaction up, but is not in itself a reactant. Notice that manganese is not written on the reactant side. It's written above the yield arrow. So manganese, because it's written above the yield arrow, is a reaction condition. It is also considered a catalyst. Anytime an element or a compound is written above the reaction arrow, then that is called a catalyst. It's something that's going to speed the reaction up, as heat would do in the first reaction of NH3. Any of those reaction conditions are something that needs to be present or the reaction won't happen as written. To summarize today, we learned that reactants are those substances present to the left, products to the right. The arrow written between is the yield arrow. The state of matter of the reactants and products are designated using SL, G, or AQ, each with their own meaning. The numbers written in front of the substances in the chemical reaction are called coefficients. And it tells those coefficients not only balance the equation, but they really in practice tell you how many of each atom or molecule actually participates in the chemical reaction and how many of each you will make on the product side. Finally, in the anatomy of a chemical reaction, writing a chemical reaction, any information, anything written above the yield arrow is a condition for that reaction. It's what must be present, otherwise the reaction will not occur as written. And finally, if your reaction condition is an element like manganese or perhaps a compound, that reaction condition is also called a catalyst.